Dear students, in today's class we'll continue with the derivation that we left incomplete in last class due to time limitation. In last class we have written equation 4, which is for L 2h upon W sin h of WL by 2h. I hope you all have studied this series for trigonometric functions. Sin h of x is x plus x cube upon 3 factorial plus x raised to 5 upon 5 factorial plus x raised to 7 upon 7 factorial plus and so on up to infinity, where minus infinity to plus infinity. Now, of this sine hyperbolic series, we will make use of only lower order terms and neglect higher order terms. Lower order terms in this case for us will be only the first two terms, because that suffices the accuracy required by us. So, using the first two terms in the sine hyperbolic function, we get L equal to 2h upon W into the bracket x means WL upon 2h plus x cube upon 3 factorial. X cube means WL upon 2h whole cube. So that will be W cube, L cube, 2 cube is 8 into h cube into 3 factorial. Now we'll simplify this by taking common terms outside. That is 2h, here W is common, L is common, divided by W, here h is common, and in denominator 2 is also common. Inside the bracket, we have taken WL common outside. So here we will have 1, 2h also we have common. So denominator of 1 will not be one upon 1, because we have taken 2h common outside, plus W we have taken common outside. So here we will have W square, L we have taken common outside. So here we will be having L square by 3 factorial means 3 into 2 into 1, but 1 I will not show here, 2 I have taken common outside, so here I will be having 4 into h is taken common outside, h square will be there. That is equal to, cancelling h and h, w and w, 2 and 2, l inside the bracket 1 plus w square l square upon 3 to the 6, 6 for the 24 h square. We will call it as equation number 5. Using equation 3, what is there in equation 3? Let us see. This is equation 3. We will write for sin h of wx upon h, that is w into s upon h is equal to sin h of wx upon capital H. But we have written for tan theta as ws upon h, and ws upon h is equal to dy by dx. Now we will equate dy by dx to sin h of wx upon h. And from this equation we can write dy equal to sin h of wx by capital H into dx. Integrating both sides we obtain y is equal to h upon w cos hyperbolic function of wx upon h plus integration constant b. So I'll write here where b is the integration constant and can be obtained with initial conditions. at x equal to 0 and y equal to 0. Thus, 0 equal to h by w cos h of 0 plus b. Cos h of 0 is 1. Therefore, b is equal to minus h by w. Now putting b value in the expression for y here, let us call it as equation 6, we get y equal to h by w inside the bracket cos h of wx by h minus 1 and let us call this as equation 7. Which means the expression for the y here we have obtained now, that is equal to h by w inside the bracket cos h of wx by h minus 1 bracket complete. And this equation 7 is called equation for sag. That is catenary. Equation 7 is equation for sag, that is called catenary. But we have cos h of x equal to 1 plus x square upon 2 factorial plus x raised to 4 upon 4 factorial plus and so on up to minus 1, where x varies between minus infinity and plus infinity. Using this expansion, in place of cos h of wx by h, we get y equal to h by w inside the bracket 1 plus 1 by 2 factorial into wx upon h whole square plus and so on up to minus 1. Minus 1 and plus 1 will cancel. So we will have h by w into 2 factorial is 2 into 1, that is 2 only, into w square x square upon h square. Now by cancelling, we get y equal to 1 by 2 into w x square upon h. This is equation for parabola. It is like y equal to ax square. So you can write equation for y is equation of parabola. If we call it as equation 8, equation 8 is valid for short span. Short span, it means the distance between two towers or poles, that is capital L. Tension T at point P will be, that is in this figure we have to write expression for capital T. Here the vertical component is T sin theta and horizontal component is T cos theta. So using these vertical component and horizontal component, we can write expression for capital T as T square equal to T sin theta square plus T cos theta square. And T sin theta square is Ws square and T cos theta square is H square. Substituting the value of S from equation 3, we get T square equal to W into H upon W sin H of Wx by H plus H square. This bracket must also be squared. Now W and W will cancel here. Whole bracket square is there, therefore it will become h square. From here and here we will take h square common outside. So h square into the bracket sin h of wx by h squared plus 1 bracket complete. That is equal to h square inside the bracket cos h of wx upon h squared, since 1 plus sine of hyperbolic function squared is equal to cos of hyperbolic function squared. Now taking square root on both sides, we get t equal to capital H cos h of wx by h. Let us call this as equation number 9. So equation 9 gives us tension acting at point P using equation we can write for the tensions at the lowest point and at the highest point, that is at x equal to 0 and at x equal to capital L by 2. T equal to h into cos h wx upon h. At lowest point, that is x equal to 0. So in this equation we will put for x equal to 0. If I put x equal to 0 here, cos h of wx upon h will become 1 and t will become equal to h. At highest point, that is at x equal to capital L by 2. Please try to understand what is lowest point and what is highest point in figure. In this figure, From ground, if you see, this is the lowest point and this point is highest point. That is, in the second figure, O is the lowest point and B or A is the highest point. So for lowest point, in the next figure, x is 0 because you have not traveled any distance in direction of x. And for highest point, x value will be equal to L by 2 because the span, that is distance between two poles, is capital L, and from this midpoint to go up to the supporting point, you will have to travel capital L by 2 distance in the direction of x. So now by substituting x equal to L by 2 in expression for capital T, we get T equal to h cos h of wx by h at L by 2. Right, at x equal to L by 2. Okay. So this will be now equal to expression for T is to be simplified for x equal to L by 2. So h into cos h of WL by 2h we get. This is tension at highest point. When x is equal to capital L by 2, y is equal to the sag or deflection D. Therefore, using equation 7, the sag D is calculated as D equal to capital H by W into the bracket cos H of WL by 2H minus 1. Let us call this as equation 10. If we use equation 8, and right here, or using equation 8, D is equal to Wx square upon 2H, that is equal to W by 2H into capital L by 2 whole square. Simplifying, we get D equal to WL square upon 8H. Let us call this equation as 11th equation. So what is this D then? Referring to figure, you can see here the maximum deflection or maximum sag is D, which is at midpoint of conductor supported by the poles which are at same level. If I call this point as Q, then AQ is equal to capital L by 2 and QB is also equal to capital L by 2. So from A at L by 2, the maximum deflection occurs in case of a conductor supported by the two poles which are at same level. Using equation 5 and 11, the length of wire that is small l between span in terms of the span length capital L and sag can be calculated as from 5 we are having L equal to capital L into 1 plus W square L square upon 24 H square. This L will write in the form so that we can substitute for D value, that is capital L into the bracket 1 plus we have D is equal to WL square upon 8H. Okay. Now here I need WL square, so I'll write W square as W into W into L square upon I need in the denominator here 8H, but here it is 24H square, so I'll write it as 3 into 8 into H into H. So capital L into the bracket 1 plus WL square upon 8H, it will become D, and here we are having one W in numerator and 3H in denominator. I will make this also as D. For that I will multiply this ratio by L square and divide by L square, and I need 8 in denominator, so I will multiply this by 8 and divide by 8. Now capital L into the bracket 1 plus 8 WL square upon WL square upon 8H is D. Remaining constants will write as they are 8 upon 3L square and another D as it is. So on simplification we will get small l is equal to capital L into 1 plus 8D square upon 3L square. Now let us call this equation as 12th equation. I will take one example. The weight of a overhead conductor of a line is 4.0 Newton per meter. The ultimate strength is 8,000 Newton. If safety factor is 4 and span length is 160 meters, find A sag and B total length of the line. Here the line means conductor between spans solution. given the span length capital L equal to 160 meters, weight W equal to 4.0 Newton per meter, and the tensile strength is 8000 Newton. The tensile strength here means it is maximum tensile strength. The working tensile strength may be calculated as the maximum tensile strength or ultimate tensile strength divided by factor of safety. So, we'll write here working stress is equal to tensile strength by safety factor that is equal to 8000 divided by 4, which equals 2000 Newton. We have equation for sag. D is equal to WL square upon 8 H, but at lowest point T is equal to H. This we have derived. Now we will substitute for various values. W is 4 Newton per meter. L is 160, so L square will be 160 square. H is equal to T, and H value or T value we have calculated as 2000, that is here. By substituting and simplifying, we get D equal to 6.4 meter. So this is calculation of sag, that is part A. Now we have to calculate total length of the line between the spans. B, total length of the line between the span between the spans. Small l is equal to capital L into the bracket 1 plus W square capital L square divided by 24 H square. Here H is equal to T. L is 160 into the bracket 1 plus W is 4, so 4 square. 160 square upon 24 into 2000 square. That is equal to 160 into the bracket 1 plus 16 into 25600 by 24 into 2000 into 2000. 8 2 ja, 8 3 ja. 2 zeros and 2 zeros will cancel. 2 10 ja, 2 128 ja. 2000 ja, 264 ja. You simplify this further. 160 into 1 plus 2 into 64 128 by 3 into 10,000. On simplifying we get 160.68 meters. Dear students, with the solution of this problem I will stop the class here and continue in next class. Thank you.